Thank you for inviting. I'm always happy to talk about performance testing and performance engineering. And thanks for great job you are doing. So I'm getting some information from you and see that you promote the topic also. So that is great. And I would say the main trend that I see is that we just follow the industry. So as industry get transformed with agile development and DevOps, again, there is a lot of different terminology here, but I would say that main trend is that it get it iterative, uh, agile, and it becomes a single process, not a lot of silo as it was before: development, testing, performance testing, operations, which all use different tools and technologies and terminology and everything. And now we get everything kind of merged in single process. So we need performance engineering and performance testing in particular need to adjust to that. So instead of, say, traditional old way of doing things, which was adjusted for waterfall process development, when we had performance testing in the end, now we need to integrate it into the whole development process. And that is not easy and far from done.
So, Alex, you talk about something called context-driven performance engineering. Could you explain a little bit what you mean by that and why that's important?
Yeah. So I borrowed this term from functional testing, where they use it for some time. It get into completely different kind of discussions there, but idea why I use it, because again, traditional way was that we say it was very established process in most cases, at least in large corporations. So you did development with waterfall process, and at the end, when finally things start to work, you and after functional testing, you did some performance testing, then you transfer it to operations. They add some kind of monitoring around it, did some process of capacity planning. So it was pretty established process, I would say. It is all changing now as processes become more dynamic. Uh, what exactly you need to do depends now on context. You not necessarily need to do the same old way, or and more importantly, not that we have single new way which will replace old way. So depending on your system, you should define what you need to do. For example, now we have with iterative development and cloud, we it much easier to do deployment or rollback changes. So in that sense, maybe uh, performance testing is not performance risk are little less than it was before when you shipped your system, deploy it. So you need to define what you do for to mitigate performance risks, which method you could use, and different methods may be somewhat complementary and overlapping. Maybe you could do more performance testing um, before you deploy, or maybe you did a little less performance testing before you deploy and uh, uh, focus more on monitoring it in production if customer risk are not so high. So for example, for a long time I had discussion with many companies, social network or say Netflix, which didn't do much performance testing because they actually did mostly canary testing when they uh, deploy their changes on small number of servers. So even if it is not working, customers try it, do refresh, and get to old code. So they could roll back and make changes. But for example, if you have bank system, probably it is not a good idea. So, and you don't need to um, copy these techniques from social networks or Netflix or some other companies. So depending what kind of environment you have, you just find optimal ways of performance testing and other methods of um, performance engineering. And in performance testing also you need to figure out should it, now with iterative development you could start performance testing from the very beginning. So we could so should you do full scale testing from the beginning, or you need to do some should you do it on every commit every day, or more sparingly? What kind of testing you need to do at what time? What should be kind of continuous performance testing? What would be some special kind of test, like for memory leaks, stability test for long time? So so that is what I meant.
Yeah. So Alex, I think this ties into something else that you've described, and that's exploratory performance testing. Is that what you're kind of talking about here?
Including, yes. So I mean, for context driven, I meant that you need to figure out what kind of testing you are doing. And exploratory performance testing is one kind of testing you may do. So kind of investigate how your system is performed. So I don't think that we should uh, uh, do only kind of automated regression performance testing, continuous performance testing. That probably is a must in most cases, because with iterative development, so you could catch regression. But again, it is just for regression, you have a lot of other things to do, which more exploratory kind of, as all performance kind of optimization. So if you work with your system, you need to figure out how it behaves under different loads, um, and probably how you want to optimize, where are bottlenecks, and that kind of more research exploratory projects than just plain automation. And I believe that it is uh, necessary part of performance testing too. So we cannot use just one way of doing performance testing to mitigate all performance risks. So you need to consider your specific context and decide what you want to do
Okay.
exactly.
So Alex, let me ask you one more question, and then I want to see if some of the folks on the call have some questions. Otherwise, I have more questions for you. Um, most, I think most of our customers are using JMeter, which has obviously been around for a long time. Um, what do you see if you look down the road? Will it stay? Will it be replaced? What do you see happening there?
And first, JMeter long time here, and it has healthy developer community. So I'm not completely happy with functionality it has now, and I see a lot of products built on the top of JMeter, including yours and quite a few others products. But it definitely became kind of de facto standard. Before it was just load runner. Now I would say, even moving more to JMeter, even load runner now able to play back JMeter scripts. So I definitely sure that it will stay for a long time. Even open source products that were not developed for a long time and still alive and around. And JMeter and Gatling probably two tools most popular at the moment and get developed. And another trend, again, with all that current trends, it looks like we have some decline in load testing tools. Some commercial tools gone, some exist but doesn't look like are developed heavily. So I see less competition. So basically, very few players remain in the field. So I would say open source, mostly JMeter and Gatling. Load runner, of course, still there, but I still not quite sure how much new development is going on there. Neotis, and I would say about it. That's about it. And few products on the top of open source, like your products, BlazeMeter, Octoperf, and few more.
Okay.
Many, again, some were like 10 years ago, I saw a lot of competition and new products, and now it kind of decline in competition. So I don't even see any real competition to JMeter in that area. And
Okay, great. I guess I would like to open it up to see if anyone has any questions that they would like to ask Alex.
I had a comment. I liked your talking about exploratory performance, and I'm going to put it in the chat session here. I don't know if people saw the Amazon write-up of their outage on Kinesis on last Wednesday. It's kind of interesting, and I think it kind of, you never know where your bottlenecks are gonna like creep up and so forth. And so their bottleneck crept up when they added more servers, and just the intercommunication of the servers basically overloaded the configuration of the number of threads that they had on their operating systems on their server fleet. And it kind of, I think, challenges everybody that worries about scaled environments to try to figure out ways to stress their environment at least occasionally, to look for these cracks that can happen at an unexpected time, the day before Thanksgiving, right? I'm sure there were a lot of people running around frantically at Amazon that day, because it was like a cascading event. But when Kinesis went, like a bunch of other services started to go as well. But if you haven't read it, it's an interesting article, and I think it kind of feeds back to your comments on exploratory performance.
yeah, and that is one more aspect. System became too sophisticated. So old idea that you need to take the whole system and run realistic tests doesn't quite work in many cases. So you need to figure out way to stress different parts of the system separately. And that is very specific to your system, how you could do that. So maybe you don't need to stress test all the system. It's good thing, but again, with huge scale of many systems, it's become almost impossible to do. But you still can figure out a lot of tests that you could do with some parts of the system, which alleviate maybe not all the risk, but 90% of the performance risk. Anyway, you cannot mitigate all 100% of risk because you can miss something in your tests. Probably you won't test for every possible scenario.
Sure. Okay. Thanks, Bob. Anyone else want to have a question they'd like to ask Alex?
Yeah, hi. So first of all, I would like to apologize for joining a little bit later and from talking from my car because I had to take a very urgent COVID-19 test. So that's the first thing I would like to say. The second thing is I hope everyone here are safe and healthy and keep distance and masks and everything else. That's the first thing I would like to say. The second thing is the way I view it historically is the way that automation developers or automation engineers are perceived in the industry. And for a very long time, they were perceived as QA engineers that has a bit more programming skills. And that has changed gradually. And now they are viewed more as software developers that has some QA characteristics or some QA qualities, so to speak. So the change that it has drove into the tools is that in the past, the tools were more GUI-like or codeless. They're still around today and they're still being developed today, but there were many of them in the past. Automation developers usually dealt with GUI codeless tools, and gradually we see that more and more coding tools are added to the mix. So either the codeless environments add some coding frameworks into them, and JMeter has done that progressively over the time. Now with the new, relatively new Groovy integration that they have, you can do more coding stuff into your load tests. So one tool that is coming up, and I think it's coming up very fast, is Locust.io. It's open source, it's Python based, and it's growing in popularity. And I think it's worth notice. I will put the link right here into the chat. Just a sec. Okay, so Locust.io is it's becoming very popular these days, and it's completely coded. This is not codeless thing. It's not like JMeter or LoadRunner or Kotlin or all the other. Well, actually, I don't have a lot of experience with Kotlin, but it's completely coded and it looks very powerful and very promising. And I think it's worth notice.
I completely agree with your statement, and actually, it has, say, more fundamental underlying issue here. Coding, in most products, you could do coding. Actually, say, my first presentation in US was how to you make DLL API calls in load runners. So load runner always had ability to put code, and actually JMeter too. The main problem is kind of technology. So if you have everything like API calls, you could do that. But we still have a lot of products that have GUI, and you need to still go through recording. I have a lot of discussion over the years with many people who say downplay recording, but that is good if you have just API, like now I move to MongoDB and mostly concentrate on server test, yes, with API, different kind of API, it is much easier and much easier to automate. But as if you have some more sophisticated GUI, like I worked with Hyperion products before, basically you cannot replace it with API calls. You have a lot of calls behind the scene. So if you just use API, it won't be exactly as it work with a real client, and you may miss a lot of issues, like client do other different calls that you think, or do multiple calls and doing wrong calls. And as soon as you need to do recording, it become more difficult to automate. So it's the step of recording and updating not easy to automate. You could kind of combine it, so but it still require a lot of manual steps.
Okay, thanks. And thanks, Eldad, for your question and your comments there. And please stay safe. So, who else? Is there anyone else who would like to has a question for Alex here?
I know we have a few more minutes with Alex. I really liked your point about context and large load testing versus finding the, to me, I interpret that as finding the context by which to do my load tests. So for me at scale, it's, you know, do I test a canary? Because setting up the part of the challenge, and Eldad, you brought up one point about building the load test. For me, a lot of the challenge is about setting up the load test, the environment, recreating my production. I can't recreate an environment that is now 10 years old and you know, infrastructure everywhere, and new services get added every other week. And so how do I replicate that? And so we found to be able to do that in the context of the service or a deployment, or, you know, we do have a small staging environment, so we do a smaller load test just to make sure we didn't break anything. So that context is interesting to me, because I think that is the way to think about, you know, not rethinking I have to load test the entire infrastructure, but like, you know, in the Amazon case Bob brought up, it's when we add n number of servers, we maybe, you know, that's something that triggers that, the context by which the work we're doing.
Yeah, I absolutely agree with that. Sorry to barge in, but the first thing to take into account is virtualization. So if, let's say you have like 6 or 7 different microservices, maybe you want to virtualize some of them so that you wouldn't test them directly, and you wouldn't encounter all the bugs and all the third-party dependencies that they have. Another thing to take into account is the auto-scaling. So if some of the microservices go through auto-scale, this is something that we had lots of trouble with. So if the auto-scale has trouble, let's say that it scales up and starts to take the load while it's not ready, it still doesn't have everything popped up, that's a problem. If it scales down, and it scales down while handling some messages or some of the logics, then you're going to have some trouble. The nature of load test is that they subject it to a massive amount of uncertainty. And the other uncertainty, you can have lots of crazy stuff. I agree with you. I take your point completely.